Hi everyone! So, today is finally the day. All exams are over and we have a lot of things to go through. First, there's an announcement that will be coming out as a separate video quite soon, so look forward to that. Second, there's a lot of building to do. And if I say a lot, I mean a lot. There. And there. What you see here are all the parts for our working TVC prototype. We got all the electronics, all the mechanics, the motors, everything. So that will be the task of today, to finish our first TVC prototype. It is only 3D printed and not yet CNC'd from aluminium, but that doesn't really matter. For testing and first prototyping, the 3D printing is just perfect. Alright, so let me move that camera so you see a little bit more of what I'm doing here and not only this thing, and we'll get started.
Alright, so we will start off with the electronics. If you don't know what this in front of me is, I recommend you go back and watch the old videos of us where I put this thing together. In a nutshell, these are the electronics that will run the motors for a gimbal. They need a lot of voltage, so there are a few more components required than just plugging the motors into an Arduino. We'll start off with replacing this Arduino Mega with my old trusty Arduino Uno, because I might have accidentally fried this one, but you haven't heard that from me. So basically, I already rewrote some of the code we have running on this one, or had running on this one, and put it into the Uno, so we only have to put the cables from here to over there. Then the next step will be testing if the code still runs. Obviously, we want to go slowly, and then we will start to configure these two over here. These two are the PQ12 and the P16 linear servos. They both have a power input on this side, and they both have 3 cables output for the potentiometer built into the linear servos, with which we will measure how far the linear servo is extended. So what we will have to do is first replug all the cables to the Uno, take these cables, put them into the power input, and then we have to reconfigure this part over here with the 2 potentiometers, so it will run with the potentiometers inside of the server. And then we will jump back to the code on the computer for a second to see how we will rewrite the code so we safely run the linear servos. Because unlike LEDs, these can run, well, only so much. An LED can run forever until it's burned out. These ones have only 5 centimeters, so we have to look after that in the code.
Plugging the cables to the Uno isn't really any magic. We'll start out with the 5 volts and put them into the in and the ground ports. The Uno. Then over here we have the arrow flags. It doesn't really matter where exactly we put them, so I'll just put them into holes 2 and 3. We don't even use them yet. And we have these 4 cables here, which we will come to in a second, and these 4 small, just to get that Mega out of the way. 2 blue cables for 1 of the motor drivers, and the other 2 green ones I'll put in the numbers 6 and 7 over here. Over here we have a so-called SPI interface. These are these 2 cables. It's a clock cable, a chip select, a output, and an input cable. So over here we have the clock, pin 13 on the Uno. Technically most of the pins you could configure by yourself, but I will just use the default layout because why make anything more difficult than it already is. Chip select is 3 down on pin number 10. And then we have to think for a second. So the yellow one is out from the MCP, so it will be in on the Arduino, which is right underneath the clock, and the fourth one is the fourth of these 4 pins. So, oops, come on. So that's that. We already replugged all the cables, so that's great. Next up, let's have a little check if the code is running properly. For that, we will need our trusty power supply over here, which I already configured to max 12 volt at max about 0.6 amps. Currently it shouldn't draw any power at all, so 0.6 amps should be more than enough. Let's just double check. You can barely read it, so you will have to trust me that it's currently at about 12 volts. It jumps around plus minus 0.4 volts, so that should be fine. And now I hope that I have all the capacitors the right way up, but still, I mean, it's a little bit overdone, but safety goggles can never damage. Then we have to watch out. We have 2 cycles on this board, a 12 volt cycle and a 5 volt cycle with a DC-DC converter in the middle. So we have to be careful to put the 12 volts in the 12 volt cycle. Otherwise, obviously, we will run 12 volts over the Arduino, which is not built for, and then I have 1 Arduino less. And I don't have an infinite amount of Arduino, so I really do not want that. Nope, nothing explodes. The Arduino is powering up. We have a LED lit up, and then I will measure the voltages on the output pins of our motor drivers, if they are the desired 12 volts or 0 volts or minus 12 volts when I turn the potentiometers. The first one we have 12 volts, turn it one direction, and it doesn't change. On the other one, that may be the right potentiometer for the job. Nope, doesn't change either. Anything change? Nope, nothing changes. Back to the drawing board. After a short check, I already found the mistake. I had a little cable turn around, so the SPI interface just didn't work. But I've got it working, and now I hope in the upper camera you can see it, and turn the potentiometer. Oops, the potentiometers are still not really plugged in. I told it in the video where I built this thing too, and they're quite flimsy, so they're just moving around is giving quite some stupid signals, but whatever. So we have negative 12, we turn it and turn it, then we get a 0, and then we have a turned around voltage of 12.44 volts again. So now we will do risky bisky. That sounded awful. We will now connect up our linear servos over here, but we will only connect up the power inputs. So it will be my job to regulate on these potentiometers when to stop the servos. So this will just be a very quick, very careful test, because if I do not switch off the voltage at the right time, we will literally run this thing straight into the ground. I will extend it too far or retract it too far, completely breaking the gears inside, and one of these is $80, so I really don't want to do that. Let's first shut off the voltage. Little hint for the future, for everybody out there: always first unplug and then switch off the power supply. I don't know if you can see it in the camera, but watch the voltage carefully. Did you see that little flick at the end? Some inductors inside of these voltage or power supplies in general might give a voltage peak when you shut it on and shut it off. So if you already have connected up your whole circuit when shutting on and off, you might actually blow up everything by having that short surge of voltage going through the whole contraption, and you really don't want to do that. Just plug out the cables and then hit the power button. We will test one after the other. We will not hook them up at the same time, because again, these have very wiggly bulks on the bottom, so if I wiggle them in the wrong way, or if I put my hand on it, it might just completely go autonomous and run into the ground by itself, and I don't want that. One thing I should have checked before I switched off the voltage was what the current setting is, because I obviously, as they are retracted, want the setting to be to first extend. So red to the red cable, the grayish one to the green cable, which is our ground potential. Okay, now I'm nervous. Congrats. I will put away this one because it's flying all over the place and getting on my nerves, and I really do not want things getting on my nerves right now, because that might be the end of days. Plug this in and be ready to plug it out again if anything goes wrong. Oh shite. Okay, I got it. You see, this thing is kind of fast. I mean, it's supposed to be fast. And I now can rule it with one hand. That's great. This one is perfectly working. Also, if you wonder, the contraption up here is because this is a cable, a flat band cable. There is an adapter, but the adapter is just not big enough to be properly plugged into this board. So there's where this cabling mess comes from. And now we're gonna look at the big servo, which should just start running like a crazy man as soon as I put this in. Yep, there we go. This gentleman is a little bit slower, but has a lot more force. This one can push 50 newtons, this one can handle 300 newtons. Ooh, yeah, that's really hard. Definitely even more push. So this is great news. Both are working perfectly fine, which now means hooking up the potentiometers. From the data sheets, I already learned that the brown cables are the wipers on the potentiometers. If you have never seen a potentiometer before, just imagine a conductor like this. Take out the parts of the side, obviously. And then you put voltage on the one side and ground on the other side. And in the middle, there will be the wiper. So it will glide over this conductor, and depending on where it is on the conductor, the resistance will be over this distance, or over this distance, or over this distance. So you will have different resistances measured on this side, on the wiper. And that is what is happening here. As soon as the linear servo extends, the resistance on the wiper will increase to a maximum value, at which point I know, well, that's the maximum extension. And also, as this is completely linear, I can always say, okay, we started at 0 volts and now, other way around, I'm sorry. We started at 5 volts, for example, and now we are at 2.5 volts, so I know exactly that I'm at the halfway point between the beginning and the end. And this is how we will measure how far these little boys are extended or retracted. On this side of the MCP, we have 8 analog inputs turned into digital. The UNO we have over here, and also the Mega, obviously have analog inputs, but I do not know for sure which processor I will use in the future. We might switch over to Raspberry Pi, which are not the best ones when it comes to analog inputs, so we're just gonna use this analog to digital converter. So brown on this one is the wiper. I will put it into position number 1. Then white over here, or gray in this case, is the voltage input. So we will have 5 volts input. This one over here is the other side of the potentiometer. You remember, it goes from the one side to the other. For this, we should have, a ground. Now I will also put back this green one. I was thinking about multiple reference points so that each potentiometer will automatically have its own reference point, but that is not necessary for now. We can just do it manually for the prototype. For later, it would be useful to have the arrangement be such that we can just put in a completely different potentiometer, or aka servo, and do not have to reconfigure anything, and it will just run perfectly smooth. But that's again for the future. For now, we only want pretty much proof of concept. This was the electronics, and we will be back with running code and see if this whole contraption works, which I strongly hope so. gonna completely fuck it up. Oh boy. That was rather stupid.